Okay, in this tutorial we're going to take a look at building plants again, but this time we're going to build a fractal-like plant. So you can kind of see the difference. There's really two things I pay attention to when I'm building plants. And one is fractals and self-similarity, and the other is the Fibonacci sequence of numbers. And maybe you know the Fibonacci sequence, which is, I don't want to bore you with too much mathematics, but remember, you just do 1 plus 1. Oops, go down into use sketching mode. All right, let's do this again. Sketching mode, draw. So 1 plus 1, right, gives you your 2, like this. And then what you do is then you take 2 plus your previous number there, so that'd be 1 plus 2 is equal to 3. That's not really an equal sign, I'll just make that like that. 3, and then you take that previous answer 2, and you add it to 3, and that gives you your 5, like that. And then you get your 5 to the previous 3, gives you 8, like that. So then you build your sequence 1, 2, 3, 5, 8, and it just goes on and on. That pattern is really important because what happens is these patterns of numbers show up in nature. Like 34 is a number in the Fibonacci sequence, and if you go count like the patterns in a sunflower, you might see the number 34 within there. So that's an important thing to know for starters. And then the other thing is we're going to look at, let me erase this stuff here. The other thing is the fractal shapes themselves in this concept called self-similarity. And what it means is basically plants basically have a fundamental shape, and then the same pattern is replicated throughout. So I'll show you I'll put the cursor to the center, and I'll start by adding a cube to the scene, and I'll scale it way down in X and scale it way down in Y. Let's see where it is. It's still a little bit too big. I'll just scale the whole thing down, and then X a little bit more. Alright, so there's my basic structure. Sometimes, well, I'll give it a color, and for the reason of so I can add some emissive color to it. That way I'll give it like a yellowish green color. I could place a bunch of lights around here to see it, but sometimes you just come down here and you turn the emission up, and then it doesn't matter where your lights are. It's just going to be that color like this. Alright, so there's my basic shape that I'll start with making a leaf. And the simplest way is, at least that I use, is I'll go and loop cut inside. I'll just make a bunch of loops real quick. And then I come down here to proportional editing. I turn it on. I use this sharp up here. This one, they kind of work backwards. This one works great up here. Alright, so then I'll make sure I see the back side, A, B, get those there. And then I'm going to press G, X. And then I'll just start bending it like this. You can see it makes it so I can make a nice bend to the shape. Alright, so I have a nice bend to my curve. Well, heck, while I'm there, then I'm going to do maybe a linear type of, or I'll do a regular smooth thing, and I'm going to scale this on Y. So I'm going to do SY, scale it here. I want to affect it all the way down maybe. So there's like that. We'll just keep it something. We won't make it anything fancy. Like that. And then I could come down here, maybe I'll do it down here, A, B. How to do that into B? I guess I did C. Alright, so there I have those there, and then I'm going to scale it on Y again, but SY, but I don't want it to go as far. I'm going to scale this down because they tend to taper back down to a smaller point down like this. Alright, so this is my basic leaf structure that I want to use. Well, so this doesn't have anything to do with the self-similarity yet. One of the things I'm going to do is I'm going to just go into edit mode and press A. I'm just going to move everything up so there's my origins down at that point. I have to put it somewhere. I just didn't want it out in the middle of the world. And then I can set it back down. And then I'm going to move it over here to the side. And then before I use the same technique as yesterday with the array modifier, I'm going to make a copy of this. I'm going to press Shift D X like that. I'm going to rotate it on Z, RZ 180. I'm just going to scale it down. So it's basically the same thing, just scaled down. Then I usually Control A and I apply the rotation. If you don't apply that rotation, you can screw up your array modifier. Alright, so then I'm going to come over here, and the point is that self-similarity means it's the same leaf, but it's in just it's a little bit smaller in this case. Maybe in this case I want it just a little bit bigger, so I'll make it a little bit bigger, and maybe I'll rotate it on Y a little bit. R, Y. like that. Okay, there's the first portion of the leaf. Okay, I'm going to do it again now. I'm going to do Shift D X, move that over here. I'm going to rotate this on Z, scale that down. I'm going to apply the rotation to that as well. Maybe scale a little bit more. I'm going to put it up here. Maybe you notice I'm facing it the opposite direction. It's still going to be a little bit smaller for this branch, like this. I'm not sure exactly where I want to go with it, like this. And then I'm going to rotate that on Y. There we go. So there's my basic little plant structure that I have right here. So then, since I have it here, I'm going to take all three of those just for the second. Usually when I'm working on something like that, Shift DX, I'll just make a separate copy over here before I do anything else with it. And then I come back to this and I'm going to join these three together. I can control J to join. Alright, so now I'm going to add my empty back to the center like we did yesterday. And so this is the process of self-similarity. So what it is, it's similar, and it's basically, I'm just using it, and you would just repeat this process, you know, one there, a little one there, and that's pretty much how fractal surfaces work. A lot of it's all about the shape of the surface and how you rotate the surface and how many there are, and that Fibonacci sequence comes into play on rotations as well. So there's a number of ways to do it, and typically if I was doing this, I would rotate this away from the z-axis, so this would be turned sideways as well instead of just on this zx plane like that. But it's kind of gives you an idea. You just start with that. Then we're going to go back in and use the array modifier like we did yesterday. Come down here, use the object offset, grab the empty like that. Let's see where they are. Oh, does it look all messed up? It does. Well, let's see if it is or not. So let's see. Let's see. Oh, well, let's take it. Oh man, that is like messed up. What is going on? Escape that. I'm going to get rid of this. Or I'm not going to get rid of. I'm just going to do that. I'm going to Control A, and I'm going to apply the scale. Oh, so therein is the point of this lesson as well, is that purpose of yesterday's lesson was to emphasize the importance of applying rotations and scales and locations, and this is one of those cases that's absolutely essential. Okay, so now that we have that in there, then we can rotate this on Z, right, like we did before. We rotate that like that, and then we can move this here, and then we go back to the array modifier, and then we'll make more copies around the circle like that, and there I'm making my little plant. You know, of course you could move this, you could orient this so it's positioned, this is positioned like that, right? So now we have this kind of little cactus kind of looking like structure. Okay, so that's good enough. So I'll put that there. I'm going to apply it. So there's my little thing. Let's see what that looks like in rendered mode. You can go right into Cycles rendered mode anyway. Even if I'm using the even all these are regular. I can just convert these. Let's do this. You go over here and you just use nodes on that. You use nodes on that one. What else do I have in the scene? Use nodes on that one. And then, oh, there's another one. Use nodes on that. Let's see what it'll look like. Emission. All right, so those are all those nodes, and we'll just see what it looks like rendered real quick. And there's our little plant structure. So I would recommend you looking up self-similarity, fractals and self-similarity, and just keep those thoughts in mind when you're building plant-like structures, and you'll find that there's a whole field to study. A lot of people think of fractals as these really beautiful fractal images, because they are, but in the mathematics world, in science and engineering, they're thinking of it as fractal geometry. It's actually a mathematical subject, fractal geometry, and it's super powerful and very, very important. So, all right, well, hopefully that gives you some ideas for your own work, and then maybe you can make some really cool plants on your own. And you know, if you have some, post a message, let me see them, and I'd like to see your work. All right, well, that's it for now, and I'll see you in the next lesson.